Hello and welcome to another Clear Sky Explainer video. Today's topic is drag, the aerodynamic force that opposes an aircraft's motion through the air and how it relates to aircraft performance. Consider driving your car and extending your hand out the window. The force you feel pushing your hand back is drag. The faster the vehicle moves, the greater the drag force. In essence, drag is the aerodynamic resistance experienced by an object moving through air. It constantly acts to slow down the aircraft and increase fuel consumption. Therefore, engineers must develop strategies to minimize drag and enhance aircraft performance. Drag is a multifaceted phenomenon. It manifests in various forms, each presenting unique challenges. The first type we will discuss is lift-induced drag. Consider the sensation of your hand being pushed back by the wind. Lift-induced drag is similar, but it is generated by the wing as it produces lift. This is the cost of achieving lift and overcoming gravity. The second type is profile drag. This drag is attributed to the aircraft's shape. For instance, a sleek Ferrari experiences less air resistance compared to a boxy London taxi. The same principle applies to aircraft. The more streamlined the design, the lower the profile drag. Now let's delve into a critical aspect of aerodynamics. Similar to how a car has an optimal speed for fuel efficiency, aircraft have a specific speed known as the minimum drag speed. This is the velocity at which the aircraft encounters the least aerodynamic resistance. It represents an equilibrium between lift-induced drag and profile drag. Identifying this optimal speed is essential for pilots, as it enables efficient flight operations and maximizes fuel economy. How do flaps affect drag? Flaps play a crucial role in aircraft performance. They increase the wing's lift at lower speeds, which is essential for safe landings. However, flaps also lead to an increase in profile drag. This leads to a lower speed for minimum drag. This can be compared to the effect of a parachute, which creates resistance. While this increased drag is a trade-off, it is necessary for ensuring a safe landing. The impact of mass on aircraft drag. Recall Newton's laws of motion. One of these laws states that heavier objects require more force to move. This principle is directly applicable to airplanes. A heavier aircraft necessitates generating more lift to remain airborne. Consequently, increased lift results in increased induced drag. This subsequently leads to a higher speed for minimum drag. Notice also that the profile drag curve remains the same. This can be compared to pushing a fully loaded shopping cart versus an empty one. The heavier cart demands significantly more effort to move. Now, let's dive deeper into how speed itself impacts drag. Generally, the faster an aircraft travels, the more drag it encounters. This can be compared to extending your hand out of a car window at high speed. The increased speed makes it increasingly difficult to maintain a steady hand. This principle is why airplanes operate at an optimal cruising speed. For example, an increase in speed leads to a proportionally increase in profile drag equal to roughly the speed squared, and a drop in induced drag equal to roughly 1 divided by the speed squared. We will dive deeper into these relationships in the drag section in Principles of Flight. Altitude, temperature, and drag. As altitude increases, the air becomes less dense, resulting in fewer air molecules for the aircraft to encounter. This reduction in air resistance leads to decreased drag, which is a primary reason for high-altitude flight. Temperature is another critical factor. Warmer air is less dense compared to cooler air, thus aircraft in warmer conditions encounter reduced drag. This can be likened to the difference between moving through water and a more viscous fluid. Movement is significantly easier in the less dense medium. The chilling effect on drag. Finally, let's discuss the impact of ice. Ice is not just problematic for your driveway in winter, it also poses significant challenges for aircraft. Ice accumulation on the wings disrupts the smooth airflow, increasing drag and reducing lift. It's akin to driving a car with a large object strapped to the roof. This is why de-icing procedures are crucial in aviation. Ensuring the wings remain smooth and free of ice allows the aircraft to maintain optimal aerodynamic efficiency. If you found this video insightful, don't forget to hit that like button. And make sure to subscribe to our channel. Share this video with your friends and fellow aviation enthusiasts. And we'll see you in the next video. Safe travels.